Okay, welcome back. So this is 4.3, right triangle trigonometry. So what we're going to be doing is kind of taking the triangle out of the circle momentarily, and then we're going to kind of put it back in and work with it there, but let's see the definitions we have. So right triangle definitions, and before the picture was of a unit circle, right? So it's a circle with radius 1, and then we would consider maybe an angle inside here, some like pi over 4 was the one we were considering. The deal is now we can kind of work with a right triangle. So if you were to drop a line perpendicular down to the x-axis from this point on the circle, and then also consider this line on the x-axis right here, that forms a right triangle. Okay? Because of the point is x comma y, we know this side here, its length is y. I wrote x, and then this side here, its length is x. Okay, so if we took that triangle there in red and kind of extracted it and then zoomed in on it, what we'd end up having would be this kind of deal. So here's my angle again, and then it's a right triangle because it's a 90-degree angle in there. This side has length y, this side has length x, and in our last sections we've been assuming this side was length 1, but now what we're going to do is a more general version of that and say the following. In general, our triangle will look like this. So here's our angle, here's our right triangle. We'll call the vertices A, B, and C. So the bottom one A, and then this guy is big B, and this guy's C. And then for the sides, this side is considered the opposite of the angle, is little a. So that's the opposite. This side over here, little b, that's considered adjacent to the angle, because the side is actually touching the angle. And then the third side is considered the hypotenuse. Okay, so little c, and we're calling that the hypotenuse. Okay, so we want to now define our trig functions in terms of these guys. In our last section, we defined them all over 1. Each one was, let's see if I can find where it was. Can I remind you guys? Did we? I mean, we had to use the unit circle. Yeah, so it was y over 1, x over 1, and then y over x, except we didn't write it, right? So it should be y over 1 because the thing was a unit circle, radius 1, right? Okay, now, though, we're going to work with this general triangle and make the definitions of the trig functions in terms of adjacent, opposite, and hypotenuse. Okay, so I'll write out all my trig functions, and then we'll do that. Okay. And then, of course, we have cosecant, secant, and cotan. Okay, so sine is going to be opposite over hypotenuse. And of course, in our picture, that will be little a over little c. Cosine will be adjacent, and we have to have these memorized. The adjacent over hypotenuse. You don't necessarily need to memorize a over c, and then in this case, b over c. That's silly. Just the opposite over hypotenuse, adjacent over hypotenuse. And then tangent will be opposite over adjacent. Okay, which in this case will be a over c. Oops, a over b. Maybe I should put the big letters in a different color or something, you know. Let me do that. So we'll put big A, big B, and big C. Okay. I probably just made it worse, but oh well. Okay, cosecant is hypotenuse over opposite. Which will be C over A. Secant will be hypotenuse over adjacent. And you can see these still satisfy the basic identities where cosecant is just 1 over sine. Secant is 1 over cosine, right? And then cotan is just 1 over tan. Okay. So we need to have these guys memorized. Memorize these. They will be used over and over again if you keep taking math. Okay, let me just look and make sure they're all right. C, A over B, C over A, C over B, B over A. Opposite hypotenuse, adjacent hypotenuse. Just a reminder, you can always slow down my videos or speed them up. There should be a button there around where the settings buttons are. Okay, let's look at problem number 3. And what they want you to do is figure out the 6 trig functions for this given angle inside this right triangle. Okay, so we'll have given to us 29 and 21, and then the vertices, this is big A, not that it really matters, big B, big C. Okay, so I need to figure out, sine of theta, cosine of theta, etc. For some reason my this weird lag in my drawings. Okay, so I'm given the adjacent. So this side right here is adjacent to the angle. This side here is the hypotenuse. I need the opposite though, right? So I need to figure out what the heck that opposite side. And you could use the Pythagorean Theorem. So the Pythagorean Theorem says, and maybe we should go to our original picture, little a squared plus little b squared is equal to little c squared. Okay? The sum of the squares of the lengths of the sides is equal to the square of the hypotenuse. Right, so we can figure out the opposite side then. It will be 21 squared plus this opposite side, in this case it's little a squared, equals 29 squared. And then solve for little a. So subtract the 21 squared the other side, we have 29 squared minus 21 squared. Okay. If you put that into your calculator, that's 400. And then take the square root of both sides, and a will be 20. Okay. So that will be our opposite side. And then we should be able to use these identities to kind of fill in the blanks. Okay. So sine will be opposite over hypotenuse. So 20 over 29. Cosine adjacent over hypotenuse, 21 over 29. And then tangent is opposite over adjacent. And then we should be able to get the rest of them just by taking reciprocals. Right? So this would be 29 over 20, 29 over 21, 21 over 20. And that should be all of them. Let me just check my notes, make sure they're all right, so I'm not misleading anybody. And we're good. Okay, so before we kind of figured out the special angle pi over 4 somewhere, yeah, right here. Okay, and we were able to kind of get that using the formula for the circle, x squared plus y squared equals 1, and then by noting that the diagonal is the line y equals x, we were able to kind of put in a and then solve out, and then use our x and y's definition of the trig functions above to figure out, that the sine of pi over 4 is root 2 over 2. Okay, we want to do the same thing now, but with right triangles. Okay, and we'll be using kind of the Pythagorean theorem. Okay, so we're also not just going to do pi over 4. We're going to do pi over 3 and pi over 6 as well. So function values for some special triangles. Okay, and we start with pi over 4. Okay, so the way I'm going to get this done is by using what's called an isosceles triangle. So a triangle is isosceles if two of the angles on the inside are the same. Sorry, I butchered that triangle. Oh, it's going to make me draw another one. Okay, well, that's... Okay, so it has two the same sides, and then this third side we'll be able to get it using Pythagorean Theorem. Okay, so I'm going to make this guy pi over 4 or 45 degrees. This guy pi over 4 or 45, and then the third is 90. So if you add them all up, you always get 180 degrees. If you add up the interior angles of any triangle, you get 180 degrees. Okay. Okay, this is a special triangle called isosceles. Isosceles has two of the same angles, and then the sides opposite of those angles are the same. You can make them anything you want. You can make the side 2, this side 2, 4, 4. For the sake of sanity, we're going to put this side as 1, and then this side as 1. Okay. Then we're going to use the Pythagorean Theorem to figure out what the heck the hypotenuse is. Right. So a squared plus b squared is equal to the hypotenuse squared, which is c squared. Okay. Plug in 1 for a and b. And then you'll have c squared is 2. And then we can take the square root of both sides. It's not plus or, usually you put plus or minus because we want positive distances only, we just use the positive root. So we get root 2, okay? Then we could use our, sine theta is equal to hypotenuse, opposite over hypotenuse and that stuff, those identities to figure out the angles, okay? So, or to figure out the trig function of the angle pi over 4 in this case. Okay, so we need to kind of write out our trig functions again, and then you should have all these memorized. Okay, usually I just learn cosine and sine, and then I can use the other identities to fill in the blanks on the other guys. Okay. Okay, so sine of pi over 4 opposite. So you could use this, I'll use the bottom angle right here. So opposite of that angle is the side 1. So opposite is 1 all over adjacent, and hypotenuse, sorry. And the hypotenuse, of course, is root 2. You could rationalize the denominator and put it into our more familiar form, root 2 over 2, okay, which you probably remember from the last section. Well, I hope you do. The cosine is adjacent over hypotenuse, so the adjacent side is just 1. And then we have the hypotenuse root 2. And again, you want to probably rationalize that when you memorize it. It's always root 2 over 2. Okay. Okay, so I generally will memorize those two, and then everything else I just figure out using the identities. If you wished, tan of pi over 4 is opposite over adjacent, so it'd be 1 over 1, which is just 1. Cosecant will be the reciprocal of sine, right? So it would be root 2 over 1, or just root 2. In this case, secant will be the same. It's just root 2, and I accidentally wrote tan. I meant to write cotan. So let's put cotan right there. And that's the reciprocal of 1, so it should be just 1. Okay? So most importantly, I would say, are these two. You really got to memorize these two. And then hopefully the other ones you'll be able to kind of figure out just by using all of the identities. Like tan is really sine over cosine. Cosecant's 1 over sine. Okay, let's get the other angles out of the way. So the next one is pi over 3. Which of course is 60 degrees. Okay, and to get this one, and we'll also sort of get pi over 6 out of the way at the same time, which is 30 degrees. In order to get these guys, we're going to kind of use 2 right triangles back to back. So if you have two 60-degree angles on this guy. 60 plus 60 is 120, 180 minus 120 is 60. So all these angles will be 60 on this triangle. And then we could drop a perpendicular line from the sort of top of the triangle to the base and cut it into two right triangles. Okay? And we're going to have the sides just all equal 2 in this case. So all the angles are the same, the sides are all going to be the same. Okay, so let's split this into two triangles. We only need one of those two triangles. Okay, so right below it, I'm just going to borrow this. This side is 2. This angle is 60 degrees. This angle is now 30 degrees because we split this 60-degree angle in two. And then we have a 90-degree angle right here. Right, those are both 90 degrees. And then this base side is 1, and then we have to figure out this this other leg right here across from the 60-degree angle. Okay, so I could do that with a Pythagorean theorem, right? So we'll say 1 squared plus b squared is c squared. 2 squared is 4. So I'll have b squared is 3, and then b is root 3. Okay, so the third side must be root 3. And from that, I can figure out all my special angles here. So we'll say pi over 3's. Oops, I always do sine first. Sorry, I'll just cheat a little bit. Put sine right there. And tan. Cosecant. Whoops. Tried to get hyperbolic cosecant. That's cosec. Okay, cosecant. Secant. And then, what do we need? Cotan. And you can probably do these on your own. You don't need me to do them, but I want to do them anyways. Just for the sake of it. All right, so I'm working with the 60-degree angle first. So that's this angle. Put in red here. And I use my identities. So sine is opposite. Root 3 all over hypotenuse, 2. Cosine is adjacent, 1 all over hypotenuse is 2. And then tan is opposite over adjacent. So root 3 over 1, just root 3. And then these other guys, 2 over root 3, it's just a reciprocal of sine. Okay. Rationalizing, you get 2 root 3 over 3. This will be 2 over 1, which is just 2. Secant is just 1 over cosine. And then cotan will be 1 over root 3. Rationalizing, you'll get root 3 over 3. Okay. Let me just make sure those are all right. Okay, those look good. We want to do the same thing now, but with pi over 6. So sine pi over 6, cosine pi over 6, tan of pi over 6, and then cosecant of pi over 6, secant pi over 6, and cotan of pi over 6. Okay, and we can use the same picture. It's just the angle we're playing with, I'll do in blue this time, is this 30-degree angle up top. Okay, so for sine, opposite in that case, when you're dealing with the 30-degree angle, the opposite is 1, and then the adjacent is the root 3. So this is opposite. And then this guy here is the adjacent. Okay. Okay, so for pi over 6, sine of pi over 6 is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So root 3 over 3, I should say. It doesn't look like it, but it does. Write it. Then tangent is opposite over adjacent, 1 over root 3. which you rationalize is root 3 over 3. And then these other guys are just reciprocals, right? So it'll be 2. Did I screw up cotan? That would be very sad. No, I didn't. I'm good. Okay, this is 2 over root 3. So rationalizing, you get 2 root 3 over 3. And then finally, cotan would be just root 3. Okay. Okay, so again, when you do these, just memorize these and then get the other ones for free, right? And yeah, up there, it's a matter of just kind of memorizing these, and then you sort of get the other ones for free. Did I already give you the chart? If not, it's kind of, you'll have to have this thing memorized. It's not going to hurt if I write it out again. You just fast forward if you've already seen it. So what do we have? Like sine, theta, cosine theta, and then of course tan theta, and then hopefully you can get the other ones, no issue. So let's see, it goes 0, and then pi over 6, and then pi over 4, and then pi over 3, and then pi over 2. So those are the angles in order in that first quadrant. Sine of 0 is, of course, 0. Sine of pi over 6 is 1/2. And the trick way to do it is just go 1, 2, and then 3, and then always put a 2 in the bottom, so you end up with root 2, and then you square root the tops, right? And then this is 1. And then if you write them in reverse, that you get the cosine. So cosine is just 1, root 3 over 2, root 2 over 2, 1/2, and then 0. And then tan is just the ratio of all those. So it's 0 over 1, 0. 1/2 over root 3 for this guy, not rationalizing. This is 1. This will be root 3. And then this will be undefined. Okay, just using all of our identities. This chart is awesome. If you get this memorized, you are ahead of the game. And it's usually the first thing I would write down when I'm taking a test. I would just dump that on the paper. Okay, one weird thing about these right triangles that you may have kind of already seen is this kind of relationship between the cosine of pi over 3 is 1/2, but sine of pi over 6 is also 1/2. That kind of co-relationship that these trig functions enjoy. Okay, so we're going to call those complements. Section 3, looking at the trigonometric functions and their complements. Okay, so if you have a right triangle of some sort, okay, and you're given one angle over here, because the angles have to add to 180. This angle plus whatever that upper angle is, I'll just call it something like alpha, plus the 90 degrees right angle has to equal 180. You know that top angle, alpha, if you move the 90 over, you'll have theta plus alpha equals 90. And then if you move the theta over, you get theta equals 90 minus theta. This top angle is 90 minus theta. Okay. So what? Well, think about the trig functions in terms of the sides of this right triangle. Okay. Sine of theta, if I label the sides A, B, and C, sine of theta is opposite, that was A, all over hypotenuse, which is C. And then what I'm saying here is that cosine is the same thing, right? Because cosine of 90 minus theta is that top angle is going to be adjacent, which is A, all over hypotenuse, which is C. They're the same. The sine of theta is equal to the cosine of 90 minus theta. Okay. And that works in the reverse way, right? Because then you'll note cosine theta must be equal to sine of 90 minus theta. And it turns out you could do that with all the trig functions, all the complementary kind of trig functions. So you'll have then, of course, tan of theta is equal to cotan of 90 minus theta, and so on and so forth. Okay. So what are the other ones? Cosecant theta is equal to secant of 90 minus theta. And of course, then cosecant of 90 minus theta is equal to secant of theta. Cotan of theta is equal to tan of 90 minus theta. So it's like you get those for free, right? So you get tan of 90 minus theta equals cotan of theta. And you also get, I'll just go ahead and write them out. Cosecant, whoops, I want to write secant. Secant of theta then would be equal to cosecant of 90 minus theta. Hopefully I got them all then. There should be 6 of them. 1, 2, 3, 4, 5, 6. Okay, hopefully I got that through. I know they're in the homework. If you look in the homework, let's see if I have one set up for us already. Yeah, sure. So if the sine of theta is 3 over 4, find the cosine of pi over 2 minus theta. So pi over 2 is 90 degrees minus theta. Those should be the same, right? So you should just be able to write 3/4 in there and be done with it. Yeah. Okay. Maybe let's look at another one, maybe from the book, I guess. The sine of 72 degrees. So these are a little more thinking. You have to think a little bit more. But you should be able to rewrite this as cosine. I don't know if there's really any more thinking. It's the same as cosine of 90 minus 72. And then, in this case, it really isn't going to help you very much, but 72, 78 is 18 degrees. You have to use a calculator on that, but I don't know. Okay, so you could use those identities. So rewrite cosecant of pi over 3 as the secant of some angle. So cosecant of pi over 3 is equal to secant of pi over 2 minus pi over 3. And then you can reduce that by finding common denominators. Times 3 times 3 times 2 times 2. So you end up with secant of 3 pi over 6 minus 2 pi over 6, which is the secant of 1 pi over 6. Maybe I should actually read the question. My cat is sitting on me. I don't want to have to upset his little world. Let me see what the question actually asked. Develop all these bad habits as a teacher, so I should be reading the question. What example is this? Example 5, I think. Yeah, using cofunction identities. So these things are called complements, but I guess they're also called cofunction identities. So let's just make note of that over here somewhere. Cofunction identities. Okay. So the actual problem was saying use the cofunction identities with the same value. Find a cofunction with the same value as the given expression. So if they give you sine, they want you to find the same thing in terms of cosine. If they give you cosecant, they want you to convert it into a secant, basically. Okay, and for sine, you're using sine of theta equals cosine of 90 minus theta. For cosecant here, because you're using the radians, it's going to be cosecant of theta equals secant of pi over 2 minus pi over 2 minus theta. And in this case, theta was pi over 3, so I plugged it in there. Okay. Hopefully that's clear. I'm sorry I kind of blew through it. Let's look at some application type problems. Let's see if I have an application set up for us. Sure. Find the distance across the lake. Surveyor took measurements in the figure shown. Use these measurements to determine how far it is across the lake. Okay, so they give us some information about the lake, 38 and 730. 38 degrees, 730 yards. So they have some sort of lake. And right triangle kind of pictured there. This angle is 38 degrees. And then I think they tell us this distance is 730 yards. And then we want to basically, I guess, find the hypotenuse length. No, we want to find this other CB length. Sorry. So it's this length here that we're interested in. So that's my question mark. Okay, let's see if we could pull this guy off. So note, what is the tan of this angle 38 degrees? Well, tan of 38 is going to be opposite over hypotenuse. And the opposite is the unknown question mark. Maybe we should give that a different, let's give that the letter Y or something, like it's a height. Okay. So it's Y all over opposite, all over adjacent. Did I say that? That's what I meant. Opposite over adjacent. Y over 730. And then you kind of use this to solve for Y. So you can multiply both sides by 730, and you get Y equals 730 tangent of 38 degrees. Make sure your calculator's in degree mode, which I have to do really quick. Okay, so that's, what is it, 730 times tan of 38. I'm getting approximately 570.34 yards, depending on how many decimals they want. Oh, they want the nearest whole number, so 570 yards. 570, push enter. Yay. Let's see if they got another one for us real quick. Telephone pole type problem, 60 feet. Find the angle between the wire and the pole nearest to the nearest degree. So 85, 60, and theta. So we have a telephone pole here of some sort. We want to figure out this angle, and they give us the sides of the thingamajig. Hold on, I've forgotten already. Let's never get old, folks. 85 and 60. 85 feet, and then 60 feet. Okay, so as the ratio of sides of a right triangle, then the cosine of theta is going to equal adjacent 60 all over hypotenuse, which is 85. There's other ways you can pull this off. You could figure out the third side and then work with the tangent. That might be what the book does. But I think this way will work just as well. So how do you pull this off? Well, what you're going to do is take cosine inverse on both sides. Believe it or not. Cosine inverse. If you took pre-calculus, it's basically like taking the log of both sides. It'll undo an exponential. So if you had like e to the x equals 35, in order to figure out x, you have to take the natural log of both sides. And that kind of undoes the e, the exponential part, so you get x is ln 35. It's basically that kind of idea. Okay, so if you take cosine inverse of both sides, here the cosine and the inverse and the cosine will cancel, and you get theta is cosine inverse of 60 over 85. Then you could put that into your calculator and kind of figure it out. But you have to use radians, so this will work in radians mode. I believe. Well, what do they want? Do they want degrees? Yeah, just put it. It should work. Let's figure out if it works. Yeah, I put it in my calculator. I got, just making sure I'm still recording. I got 45.0991 degrees. So I think that'll work. Let's see what the you know, the computer says round to the nearest degree. So I just want to put 45 in there, 45 degrees. Hopefully that'll be it. Yay. Okay, so other ways you could have done that. Other ways you could have done that was to get to like the third side and then use tangents. So 60 squared plus b squared equals 85 squared. So b squared equals 85 squared minus 60 squared, and then take the square root on both sides. I forget what that is. 5 squared minus 60 squared. 3625. And then I need the square root of that. Hopefully it works out nice. Oh, of course not. So b is the square root of 3625. And let's see. So you could also say then tan of theta is equal to, opposite over adjacent. So you have square root of 3625 all over the adjacent is just 60. And then take tan inverse on both sides. So you get tan inverse of tan theta equals tan inverse of the square root of 3625 all over 60. And you get theta equaling that thing that you put in your calculator. You should get the same answer. So it's a way of kind of checking if you are really worried about issues. So square root 5 divided by 60, and I lost a parentheses, and I'm getting a different answer. Whoops, I put it in wrong. 3625. I'm still getting the wrong. Oh, I still put it in wrong. So this would be end parentheses, and then get that. And I got the same answer. So yeah, either way you slice it, you're gonna get 45 degrees. This is 45 degrees. Okay, so I think that'll get you through the homework. Let's go take a look at maybe some of these other homework problems, see what you're up against. What did it do? It just disappeared? Where is it? Okay, use Pythagorean Theorem to find the length of the missing side. So you can handle that one. You don't need me for that. Pythagorean Theorem. Pythagorean Theorem. Okay, this is one where you got to go through and figure the third side and then use all of the identities, opposite over hypotenuse and stuff. Use a triangle shown to evaluate the following expression. So secant, remember, is 1 over cosine. So it's going to be hypotenuse over adjacent. So hypotenuse is 2. All over adjacent is root 3. Let's see if it allows you to put in without having to rationalize. Although your answer is, so you're going to have to rationalize. I apologize on their behalf. So that is going to be 2 root 3 square root 3. Well, it doesn't like the square root 3 all over 3. Oops. Didn't like that. Thought we were pals. There we go. Let's clear this out. Over 3, and then let's see. Then I should be happy with it. If I can figure out how to put how to say enter, please. Yeah, there we go. Okay, so you can't use, you got to rationalize your denominator. Cosine of 45 root 2 over 2. You should already know that by heart. You shouldn't have to use the triangle. Squirt. Well, you do squirt. Oh, you got to do backslash. So some of the codes, the shortcut. Backslash SQRT will give you square roots, and then just use well, it didn't. Sometimes it's easier just to use the buttons, I guess. Square root 2 over 2, okay. And pi over 6. So pi over 6 is a small angle, 30 degrees. So sine opposite is 1 over hypotenuse is 1/2, which you should have memorized anyways. Okay, I think you're going to be all right. What is this? Root 2 over 2 plus root 2 over 2 is 2 root 2 over 2. So it's backslash sqrt of 2. That should do it. Yeah. Okay, I think you're going to be all right. So this is just more of that same stuff. Okay, you're going to be all right. Okay. We'll call the video. Oh, let's make this question the quiz question for the day. All right, so I'll make sure to put it in the video questions. So this will be the third problem and the first set of 4 that you need to submit to me. Sine of pi over 6 times cosine of pi over 6 minus tan of pi over 3. You just got to tell me what that equals. And that'll be the quiz for this section. Okay, thanks for watching. We'll see you next time.